The video begins with a view of Earth from space. The scene transitions to a network of satellites orbiting Earth. Satellites play a crucial role in global communication. These satellites facilitate internet access worldwide. They transmit data signals to and from ground stations. This enables internet connectivity in remote areas. Traditional internet relies on cell towers and underground cables. These infrastructures are often limited by geographical constraints. Starlink offers an alternative via a satellite constellation. This system aims to provide global internet coverage. Starlink seeks to overcome the limitations of terrestrial systems. It reduces reliance on ground-based infrastructure. Starlink is a satellite constellation designed for global internet coverage. The satellites orbit Earth at high speeds to ensure continuous connectivity. Their strategic placement provides broad coverage to remote areas. This network aims to deliver high-speed internet access worldwide. Starlink is a global satellite internet system developed by SpaceX. It aims to provide high-speed, low-latency internet access worldwide. The system relies on a large constellation of satellites in low Earth orbit. SpaceX's factory is where these advanced satellites are manufactured. The scene depicts a remote area with limited internet access. This lack of connectivity highlights the problem Starlink aims to solve. Limited access creates barriers for communication and information. Starlink seeks to bridge this digital divide with satellite internet. Providing internet access to ships and remote maritime locations presents unique challenges. The vastness of the ocean makes it difficult to establish reliable network infrastructure. Traditional land-based solutions are not feasible for vessels at sea. Satellite technology is often used, but can be expensive and have latency issues. Maintaining consistent connectivity in harsh marine environments is also a major hurdle. Desert landscapes present unique challenges for traditional internet infrastructure. Harsh climates can damage sensitive equipment, increasing maintenance costs. Vast distances between communities increase the cost of cable deployment. Sandstorms and extreme temperatures affect signal reliability and uptime. Limited accessibility complicates infrastructure, maintenance, and repair efforts. These factors make traditional internet solutions less viable in deserts. Many rural regions face challenges with slow or unreliable internet access. Traditional internet infrastructure struggles to reach remote areas. This lack of connectivity hinders education, business, and healthcare. Alternative solutions like satellite internet are needed to bridge the gap. Starlink offers a potential solution by providing internet via satellite. Starlink is a satellite constellation designed to provide high-speed internet access. It operates using a network of satellites in low Earth orbit. LEO. These satellites work in concert to deliver broadband internet to various locations. This system aims to provide reliable internet, especially in underserved areas. Starlink satellites orbit much closer to Earth than traditional satellites. Closer orbits significantly reduce latency or lag time for data transmission. Reduced latency results in faster internet speeds and improved responsiveness. This makes Starlink superior for applications needing real-time data transfer. Starlink satellites feature a unique flat design for optimal functionality. The flat structure helps in aerodynamic efficiency during orbit adjustments. These satellites are designed to be lightweight to reduce launch costs. The lightweight design also allows for more satellites per launch. This design contributes to the overall efficiency of the Starlink network. Starlink satellites are designed with a compact form factor for efficient deployment. Their size allows for a high volume of satellites to be launched per mission. The compact design helps reduce the overall launch costs. The small size also minimizes their visibility from the ground. Starlink satellites are designed to be relatively lightweight. Each satellite weighs around a few hundred kilograms. This lightweight construction is crucial for launch efficiency. Lighter satellites reduce the cost per launch. It allows for deploying more satellites in a single launch. This contributes to the overall cost-effectiveness of the Starlink network. Starlink satellites are equipped with solar panels to generate power in orbit. These panels convert sunlight into electricity, essential for satellite operations. The electricity powers communication systems and other onboard equipment. Efficient solar power is crucial for the satellite's long-term functionality. Starlink satellites use phased array antennas for internet signal transmission. Phased arrays allow precise beamforming to target specific areas on Earth. These antennas consist of multiple elements with adjustable phase shifts. By controlling phase, the signal can be steered electronically. This enables efficient and focused internet service delivery. Starlink satellites use laser links for in-space communication. Laser links enable direct data transfer between satellites. This technology reduces reliance on ground station. It allows for faster and more efficient data routing. Laser links improve global network coverage and reduce latency. This enhances the overall performance of the Starlink network. Starlink satellites use navigation systems for precise positioning in orbit. Onboard computers process data to maintain the satellite's designated location. These systems enable satellites to adjust their orbits as needed. Navigation systems are crucial for avoiding collisions with other satellites. Precise navigation ensures consistent and reliable internet service. Ion thrusters are used on Starlink satellites for movement in space. These thrusters enable precise orbital adjustment. They help maintain satellite position and altitude. Ion propulsion ensures efficient long-term station keeping. Starlink satellites function as a unified network. They do not operate as isolated machines. The satellites work together to provide internet access. This coordinated approach enhances network performance. This is an overview of a SpaceX factory. The factory specializes in mass-producing Starlink satellites. Starlink satellites are manufactured here. The factory operates during the day. Robots are used to assemble components. The robots work on Starlink satellites. Robots perform automated assembly tasks. Automation increases production speed. Robots ensure precision in assembly. The process highlights advanced robotics. Starlink satellite electronics undergo rigorous testing to ensure optimal performance. Testing verifies the accuracy and reliability of communication system. Power system functionality is assessed to guarantee stable energy supply. Engineers meticulously analyze data to meet stringent operational standards. Communication accuracy of a Starlink satellite refers to the reliability of data transmission. Checking involves verifying data integrity between the satellite and ground stations. This process ensures minimal data loss or corruption during communication. Accurate communication is crucial for Starlink's internet service performance. Starlink satellites require robust power systems for continuous operation in orbit. Power system checks ensure all components function within specified parameters. Testing includes solar panel output, battery charging, and power distribution. Voltage, current, and temperature sensors provide real-time performance data. Software simulations model various operational scenarios and potential failures. These checks guarantee a reliable energy supply for critical satellite functions. Starlink satellites undergo rigorous testing to ensure space durability. These tests simulate the harsh conditions of the space environment. Testing includes extreme temperatures and vacuum conditions. Satellites are also tested for radiation and micrometeoroid impacts. The goal is to verify the satellite's ability to withstand these stresses. Satellites are stacked tightly for launch. Stacking maximizes the number of satellites per rocket. This increases launch efficiency. Starlink satellites use this method. Falcon 9 launches Starlink satellites. The launch highlights reusable rocket cost-effectiveness. Reusability significantly reduces launch expenses. This makes space missions more economically viable. The Falcon 9 rocket's first stage returns to Earth after stage separation. This landing demonstrates a key aspect of SpaceX's reusability program. The first stage uses its engines to slow down during re-entry. Grid fins help steer the stage towards the landing location. Landing legs deploy for a controlled touchdown on a landing pad. Successful recovery allows for refurbishment and reuse of the stage. The satellite stack separates in space after the rocket launch. This critical phase deploys satellites into their designated orbits. Precise separation ensures each satellite achieves its mission. The process involves releasing satellites from the launch vehicle. Satellites then independently navigate to their operational positions. Successful separation is vital for mission success. Satellites are deployed into orbit from a launch vehicle or rocket. After separation, each satellite begins to slowly spread out. This spreading is due to slight variations in initial velocity. These velocity differences cause orbital drift over time. The satellites gradually disperse along the orbital path. This controlled spreading helps achieve mission objectives. Starlink satellites use ion thrusters for precise orbit adjustments. These adjustments maintain optimal positioning in low Earth orbit. Ion thrusters provide efficient and controlled propulsion. This ensures consistent global internet coverage. Starlink satellites are deployed into specific orbital paths. These paths are carefully calculated for optimal global coverage. Precise positioning minimizes interference between satellites. Achieving this requires accurate orbital adjustments. satellites. Satellites use onboard propulsion for path correction. This ensures consistent and reliable internet service. Starlink satellites are equipped with automated collision avoidance systems. These systems actively monitor the satellite's trajectory and nearby space objects. The satellites autonomously adjust their orbits to avoid potential collisions. This helps to maintain a safe space environment. Laser communication uses focused light beams for data transmission in space. Satellites equipped with laser terminals can establish high-speed links. These links facilitate efficient data transfer between satellites. Data is encoded onto the laser beam and transmitted across space. Receiving satellites decode the laser signal to retrieve the data. This technology enables rapid and secure data relay in space networks. Starlink satellites create a moving web of internet coverage around Earth. This web provides global internet access, especially in remote areas. The animation illustrates the dynamic nature of this satellite network. As Earth rotates, the Starlink constellation maintains continuous coverage. Starlink user dish installation is designed for easy setup on the ground. The process emphasizes simplicity, allowing users to quickly establish a connection. Users can set up their dish with minimal technical expertise. The ease of installation is a key feature of the Starlink system. Starlink dishes use automatic tracking to maintain connection with satellites. The dish continuously adjusts its orientation to follow satellites moving across the sky. This ensures uninterrupted internet service as satellites orbit the Earth. The system uses sophisticated algorithms to predict satellite movement. Starlink dishes can seamlessly switch connections between different satellites. This switching ensures continuous internet service. The process happens automatically without user intervention. Seamless switching maintains a stable connection. This technology enhances the reliability of Starlink's satellite internet. The Starlink dish establishes a connection with orbiting satellites. These satellites form a network in low Earth orbit. Satellites relay data between the dish and ground stations. Ground stations are connected to the internet backbone. This system provides internet access via satellite technology. Starlink provides high-speed internet access to users in remote locations. It utilizes a network of low Earth orbit, LEO satellites. These satellites communicate with ground stations and user terminals. This allows for broadband internet connectivity in underserved areas. Starlink's effectiveness is demonstrated by its reliable service. Space debris refers to defunct man-made objects in orbit around Earth. This includes non-functional spacecraft, rocket stages, and fragments. The increasing amount of space debris poses a significant threat. Collisions between debris and operational satellites can occur. These collisions generate even more debris, creating a cascade effect. This effect increases the risk to future space missions and infrastructure. Bright satellites can negatively impact astronomical observations. Satellites reflect sunlight, appearing as streaks in telescope images. These streaks obscure celestial objects and data accuracy. The increasing number of satellites worsens this interference. This poses a challenge for ground-based astronomy. SpaceX uses darker coatings on satellites to mitigate their impact on astronomical observations. These coatings are designed to reduce the satellite's brightness in the night sky. Dimming the satellites helps minimize light pollution affecting telescopes. Darker coatings absorb more sunlight, reducing reflection towards Earth. This approach aims to balance satellite functionality with astronomical research needs. Starlink satellites are designed for safe burnup after their operational life. This design minimizes the creation of space debris. The satellite's components are engineered to disintegrate upon re-entry. Controlled burnup ensures minimal risk to Earth. This proactive approach helps maintain a cleaner space environment. Starlink satellites use collision avoidance systems to prevent in-orbit accidents. These systems monitor the position and trajectory of each satellite. They also track other satellites and space debris in their orbital paths. If a potential collision is detected, the system automatically adjusts the satellite's orbit. Starlink represents a novel approach to global communication. It aims to connect remote areas with limited connectivity. Starlink also targets underserved populations worldwide. It provides internet access where traditional infrastructure is lacking. Starlink satellites begin their journey on factory floors on Earth. Satellites are transported to launch facilities for deployment. Reusable rockets carry the satellites into space. Thousands of Starlink satellites now orbit the planet. Starlink has expanded internet access globally. It brings internet connectivity to space. This enhances worldwide communication. Starlink aims to bridge the digital divide. It provides internet to underserved areas. This innovation improves global connectivity. The Starlink system is designed for continuous evolution. Ongoing technological improvements drive this evolution. Efforts are focused on addressing existing challenges. These efforts aim to enhance overall system performance. Advancements include increased bandwidth and reduced latency. Future iterations will likely incorporate new technologies. Thank you for watching this episode. We hope you enjoyed learning about this innovative technology. There are many more technologies to explore. Subscribe to our channel for more how it was made videos. Stay curious and keep exploring the world around you. Join our community to learn about other fascinating technologies.